Ice is usually less dense than water. That is the very reason the icebergs float on water. No other material has this property. The other materials in solid form are more dense than the liquid counterparts, so the solid sinks. This is the summary of the crystal bonds. The covalent, they share the electrons. Examples of covalent bond crystals are diamonds, and they are very hard and they have high melting point. The next type of crystals is ionic crystals. These crystals are formed with the electrical attraction between a positive and negative ion. Example is sodium chloride. And the properties of these materials are hard, high melting point. Metallic crystals are formed by electron C, and examples of these metallic crystals are copper, and they can be deformed. The properties of other metallic crystals are metallic luster, high electrical and thermal conductivity. The last crystal type is molecular crystals, and these crystals are formed by the van der Waals forces. The example is ice or snowflake, and these materials are usually very soft and low melting point. What is a solution? There are two parts to any solution. First one is solvent, the other one is solute. The solvent is the substance that does dissolving. Sometimes solvent is defined as the substance that is present in the large amount. And solute is the substance that is dissolved, and this is referred as solute, and it needs to be defined as the substance present in the least amount. Solutions may have more than one solute, but they can have only one solvent. Properties of a solution. A solution is a homogeneous material, and a solution does not have a fixed composition, unlike a compound. All states of matter can form a solution. We will restrict our discussion to liquid solutions. Solution concentration compares amounts of solute with the amount of solvent. So when we talk about concentration, it means we are talking about how much solute is dissolved in a solvent. If more solute, it means it is more concentrated. Less solute is the less concentrated material solution. Concentrated solutions have larger amount of solute. Dilute solutions have small amount of solute. Solution saturation. It compares the amount of dissolved solute with the maximum amount of dissolved solute possible. So if it takes the maximum amount possible, then it is called saturated. It means after that point, anything you add extra, it's going to be deposited at the bottom. So this saturation depends on the particular given conditions. Let's say like a temperature, you have to keep it constant. So if you change your other conditions, then there is a possibility that it could take a little bit more solute, but we have to make sure that all the conditions are taken care at the constant or particular temperature or particular condition, particular pressure conditions. It should be checked. Solubility. This term describes the maximum amount of the solute that can be dissolved in a given amount of solvent. So two main factors that affect the solubility is, first one is the temperature. The most solvents will dissolve more solute at high temperatures. So let's say it can dissolve, let's say 10 grams of solute. Then if we increase the temperature, maybe it is a possibility that it could dissolve up to 15 grams of solute. So the temperature is a very key factor to affect the solubility. The next one is the pressure. Most solvents will dissolve more solute at higher pressures. So these two are the constraints one has to be careful about whenever they are trying to find out the saturation conditions or solubility conditions. Unsaturated solution. Unsaturated solution contains less than the maximum amount possible. As more solids added to the solution, it could dissolve. So once it stops dissolving, then we call it's a saturated solution. Any below that, we call it unsaturated solution. Saturated solution. Saturated solutions contain all the solute it is possible to dissolve under a given set of conditions. As more solid is added to this solution, it will not dissolve. Supersaturated solution. Supersaturated solutions are unstable solutions that have been forced to dissolve more solute than it should be possible under a given set of conditions. So when the temperature is fixed and when the pressure is fixed, how much ever the solute is dissolved in the solvent, then when you increase the temperature or when you increase the pressure, it is possible that more solute can be dissolved in solvent. If a crystal of a solid is placed into the solution, the crystal will grow. The solutions are commonly prepared by raising the temperature of a solution during the dissolving, then allowing the solution to slowly cool down. So when it is cooling down, the whatever was dissolved, it will just precipitate at the bottom. So that's how we make the crystal. We prepare the crystals. Solubility rules. Both gases and solids can be used as solute in a solution. General effects, boiling point increases. The boiling point of liquid increases when the solvent is added, either gaseous or solid. Freezing point suppression. So the freezing point of a liquid decreases when solvent is added, either gaseous or solid. So whenever something like if you have a salt water solution, so whenever you compare to the water to salt water, the boiling point of the salt water solution will be increased. And if you want to freeze it, the freezing point temperature of just the water to salt water would be lower. And the effects are dependent upon the concentration of the solution. So if it is diluted or if it is more concentrated, based on that, these numbers would change, the boiling point or the freezing point temperatures. Boiling point elevation. The normal boiling point is the temperature at which a solution's vapor pressure equals the atmospheric pressure. The vapor pressure of the solvent is lowered by the solute, so the boiling point must go up. For example, if you add a small amount of salt to the water, the boiling point is raised about half degree. But if you add amount of sugar to the water, the boiling point is raised by about 1 degree. So depending upon what type of solute it is, the temperature is increasing. In both the cases, it is increasing. Only thing, based upon what solute it is, the amount it is in the temperature is increased is varying. So based on the solute, the boiling point temperature of solutions would be different. And using the elevated boiling point, one of the everyday example, most brands of macaroni and cheese require the cook to put small amount of salt in the water used to cook in the macaroni noodles. Do you know why? The boiling point of the salted water is higher than the boiling point of the ordinary fresh water. The higher the temperature causes the macaroni to cook more quickly. So that's why they add a little bit of salt in the water. That way it will take a little bit longer time to boil and that water will be a little bit hotter, and thus the macaroni cheese will be cooked a little bit faster. Freezing point depression. When a solvent freezes, it adopts a crystalline form. The solute gets in the way of the solvent particles as they try to rearrange themselves in the crystalline form. The result is that more energy must be removed from the solution in order for the freezing to occur. So if you have a pure solvent, the left side of the picture it would be like. But if solution in a solid form, then the solute will be in between of the material. That way, even it freezes, you will have all these particles in between. Freezing point depression. If you add sugar to water, the freezing point of the water will drop from 0 to -5 degrees Celsius. In water or ethanol solution, the freezing point can be significantly reduced. For very strong vodka, as low as -20 degrees Celsius. Temperature and pressure. The effects of the temperature and pressure are different for solids and gases in solution. Gas in solution. If temperature is increased, the solubility is increased. If pressure is increased, solubility is increased. So this is opposite of the solids and liquids when you add them to the uh, solvents. So in gases, if the temperature is increased, the solubility is decreased. If the pressure is increased, the solubility is increased. And in solid and solution, if temperature is increased, the solubility is increased. Everyday example, soda. Raise the temperature. So whenever we take the soda out of a refrigerator and when we remove the cap of it, because the temperature inside the bottle was a little bit lower, and when we open the cap of it, outside temperature will make the soda to be a little bit higher temperature. So once its temperature a little bit raised, whatever the carbon dioxide which was dissolved in that solution would try to come out in bubbles. That's where everything forms bubbles and it just tries to pop out because it is no more dissolved into that solution anymore. So the raised temperature, which would be unrefrigerated or lower pressure, which is removing the cap, the gas quickly comes out of the solution forming bubbles. This effect of gas coming out of the solution is called effervescence. Effervescence, the escape of gas from a liquid solution. And you can see the picture right here. The soda is dissolved in the soda has the carbon dioxide particles and the gas in it. And once we open this one, the temperature is increased and the pressure is low. So now the carbon dioxide bubbles are coming out of this thing right here. And you can see in this example right here, at a low temperature, the ice is like this. And once the temperature is high, it is dissolved completely into this. And you can see that once we increase the temperature when we leave it outside, means the temperature is increasing, so it's completely dissolved.